So this video is going to go through the basics of arrow pushing, and we'll talk about how we use arrows to illustrate the flow of electrons in reactions. And then we'll also have a few examples of using arrow pushing to illustrate how products form within a reaction. So arrow pushing in organic chemistry is used to represent the movement of electrons. And specifically, they're used to illustrate how electrons move to form and break bonds. And so arrows will always start at the initial location of electrons. And so this can either be a lone pair or a bond. And then arrows end at the final location of the electrons. So that could be either a new bond that forms, or it could be a new lone pair somewhere in the molecule. And so let's show some examples of bonds breaking. And so we'll start off with some pretty straightforward examples. So let's do something like this. And so we could show this carbon-bromine bond breaking to form this product right here. And so to show that this bond broke, we would start the electrons at the place of the bond. So we're starting at the location of the bond, and then we're drawing the arrow to where the electrons end up. And so the electrons in this case will end up on the bromine, because you can see that in the starting material, we have 3 lone pairs on the bromine. In the final product, we have 4 lone pairs on the bromine for it to have that negative charge. And so we would draw that arrow from the bond to the bromine. And so we would only have this one arrow here to illustrate that that carbon-bromine bond broke. We could also do an example of something like this. Let's say that we have a resonance structure. And so in the next couple of videos, we'll talk about resonance. But for now, I'll just draw out the product that would form, or the resonance structure, I should say, that formed. It's not really a product. But here we can see that we broke this double bond right here, since we only have a single bond in that same spot on the right side. And I'm going to put breaks in quotes because it's not quite breaking when it's a resonance structure, but we can essentially mimic it as if it is breaking. And then we can also see that the new electrons ended up where this blue double bond is. So initially we didn't have a bond there. We only had a single bond, but we ended up with a double bond. And so those 2 electrons that were initially in that green bond end up where that new double bond is formed. And to show the movement of this, we would start at the bond that broke, and then we would transfer the electrons or draw the arrow to where they end up, which is going to be between those 2 carbon atoms to form that new double bond. And so here we're not drawing an arrow to an atom, we're drawing the electrons to that new location of the double bond. And so in comparison to that top one, where we drew the arrow to the bromine because those electrons ended up on the bromine, in this one, we draw it to the bond location. All right, let's do some examples of a bond forming. So let's start off with this structure here. And then we're also going to do a resonance structure here, where we end up with this new product. And so here we can see that we formed a double bond. And so to illustrate that this bond forms, we have to show the movement of those electrons to that new location. And so we know that the electrons start off on that oxygen. Actually, I have a good charge. So we know that those electrons were initially on that oxygen because in the starting material, we had 3 lone pairs, and in the final structure, we only have 2 lone pairs. And so we start at the lone pair, and draw it to the location of the new bond, which is between those two carbons. We could also do an example where we form a new bond with an atom. So let's say we have something like this. And for this example, I'll draw in all the lone pairs on the bromine. In this reaction, we could get a new bond between that middle carbon, where that positive charge is, with that bromine. And so in later chapters, you'll go through like how to predict what products would actually form. But given the starting material and the products, you should be able to identify that this bromine is now bonded to this carbon right here. And so I highlighted those in blue to help illustrate that. All right, and so from here, if we want to show the formation of that bond, we start at where the initial electrons were, which is on that bromine, and draw an arrow to their new location, which is where that middle carbon is. And I'll put a dot on that carbon to help show that. And so here we have that one arrow to show the formation of a bond. And actually this example up here also shows the formation of a new bond. It's not just that initial bond breaking, we're actually also forming this bond right here on the right. All right, so let's do some examples of some resonance structures. So here I'll just draw out some different structures, and I'll draw out the four resonance forms that can form. And so for this one, we just want to show the movement of electrons to show the new products that can, or the new resonance forms that we can get. All right. And so here we have these three different resonance structures. And so we could show the flow of electrons by using those arrows. And so to go from that first one to the second one, all we have is that this double bond shifts over. And so we start the arrow where the double bond was and shift it over to where it ends up. And so again, that arrow always starts at that double bond and ends up where that double bond ended up. We have, and I'll highlight them in green to show where those electrons initially were and where they ended up. Next, we can go from the second one to the third one. So here we have these electrons that I highlighted in orange that end up in a new spot, which is right here. And so we can show them shifting over by going from where they were initially to where they ended up. And so that's an example of one type of resonance. The other type of resonance that you might see is where you have lone pairs involved. And so I'll draw out another example where we can see the movement of a lone pair of electrons. And so this one, we're going to start off with 3 lone pairs on that oxygen. Then we're going to end up with a lone pair on this carbon in the middle. And then next, we're going to end up with a double bond here. And this. And so here would be a good time to just pause the video and try to draw out the arrows yourself, just to practice. But I'll go through it. So here we can see that we started off with 3 lone pairs on this oxygen. And one of those lone pairs ended up forming a new double bond. And in that same reaction, or in that same step, I should say, we also had this double bond break and form a lone pair in this middle right here. And so we know that since we had two steps or two separate electron flows, we'll end up with having two separate arrows within to go from the first form to the second resonance form. And so let's start with the orange ones. So we start with this orange lone pair, and those electrons end up in this double bond right here. And then for this green pair, we start where they initially were, which is at that double bond. And then we end up drawing the arrow to the carbon where they end up having that lone pair. And so sometimes it's a little bit tricky to know exactly where which electrons line up or end up. And part of it is just getting used to certain types of reactions, which will, as you continue in organic chemistry, they'll become more intuitive. But generally a tip or a trick that I have is that you never move more than one carbon over. It's very, very rare that you have electrons jump more than a certain number of spots away. And so usually you go from adjacent atoms to the bonds to help illustrate that. All right, next we can go from the second form to the third form. And so here I'll help illustrate that by, I'll keep the green lone pair on the bottom as green. And that ends up as this double bond next door over here. And then we also have in that same step where this red double bond broke, and we ended up with this lone pair on the oxygen. And so again, we're going to have two separate arrows because we have two separate movement of electrons. And so for this first one, we're going to start with the lone pair in the green, draw an arrow to where it ended up. And then we're going to do the same thing for the red, start where they were initially and draw them to where they ended up, which is on that oxygen. And so that ends up with those two arrows to illustrate the resonance forms. Next, we can do some examples of reactions. So let's start off with an acid-base reaction. And so for this one, we can draw out something like a carboxylic acid. So carboxylic acids are very acidic, so they can react as acids. And then we can draw out something with an amine. Something like this should work. And then here, this nitrogen has a lone pair of electrons. And then once you go through the acid-base unit, you'll be able to predict these products, but for now, I'll draw these out. And so to understand what arrows we need to draw, first we have to identify what bonds were formed or broken. And so we can see that this oxygen-hydrogen bond was broken because we ended up with just this oxygen by itself, which has 3 lone pairs right here. And we initially had 2. And so those green electrons from the bond went to the oxygen. We also have that this lone pair in the nitrogen is no longer a lone pair in the products. And so those electrons likely formed a new bond since the nitrogen right here doesn't have a lone pair. And so very likely those lone pairs formed a new bond with a hydrogen. And so the hydrogen that they could have formed a bond with is right here, highlighted in red. And so to illustrate the formation of the bond, we go from the lone pair to the hydrogen. And so that first arrow here illustrates the formation of this red bond on the right. And then we also have to show the bond breaking, going from the oxygen hydrogen to the lone pair on the oxygen. And so altogether, we can see that we end up with a new bond between the nitrogen and the hydrogen, and then broken bond between the oxygen and the hydrogen, and a lone pair instead. We could also do something like a substitution reaction. So let's take this molecule right here. into this reaction here, where we start off with this bromine containing compound and add in a, what should we use? We can use something like a cyano group. Now I'll draw out the structure here. And so in this group, we have a lone pair of electrons on the carbon. And so that's where that negative charge comes. And then the product that we could get here is this. And again, at this point, you shouldn't be able to predict the products of these reactions, but given the products, you should be able to draw out the arrows that represent the reaction. All right, so for this one, let's identify what bonds were broken. So we see that this carbon-bromine bond was broken. It no longer exists in the final product. And then we can see that a carbon-carbon bond right here was formed. And so we want to show both of those. And so for this, we would use the electrons on the carbon right here. I'll highlight them in blue. So those electrons can be used to form a new bond right here. And then the bond that broke is going to be those electrons on the bromine, the ones that I just highlighted in green. So we're going to start to show that the bond broke. We start from the bond and move it over to the bromine to show that those electrons ended up on the bromine. All right, so those are some examples of the basics. I'll also be posting the solutions to this basics to arrow pushing practice problem set, which I recommend doing just to get used to practicing these reactions.